Good morning, all of you. So many of you have not solved yesterday's assignment. First thing, those who have not solved, at least today you complete it, because again today I am going to give you 4 to 5 questions on first law of thermodynamics. That is our today's concept. Got it? So don't neglect, and if you are not getting any problem, you just send me on my personal number. I will send the solution. Got it? Right? Or you can send in group also, but don't skip doubts. Okay? So let's start today's class. In today's class, the next topic, that is first law of thermodynamics. What is that? First law of thermodynamics. So let's see, what is this law? So according to this law, heat given to a system, here what this law is saying, heat given to a system, heat given to a system, that is delta Q, is equal to sum of increase in its sum of increase in its internal energy. Internal energy is what? You know, delta U. It is increased, that's why delta U. And the work done. And the work done. That is what we can say, delta W. So what is the guess? The heat given to a system, delta Q, is equal to sum of increase in its internal energy and the work done by the system against the surrounding. Against the surrounding. So this is what your first law. So that is equal to delta Q is equal to delta U plus delta W. You can keep it in a box. This is what your first law of thermodynamics. Okay, understand, very important. So first law of thermodynamics is what? Heat given to a system, means we are supplying some heat to the system, is definitely equal to the sum of whatever the internal energy is increasing plus work done the system is doing against the surrounding. Got it? So what is this statement all about? We can see here some note points we can say. So see here, it is a statement, of conservation of energy in a thermodynamic process. In a thermodynamical process, right? So if they will ask you, is this statement is a conservation of energy in thermodynamics, you should say yes, it is, right? Next point, see here, delta Q and delta W are the path functions, are the path functions, but delta U is point function. मतलब अगर हम path की बात करें, so these two are dependent, but this is not dependent, this is a point dependent. Next one, which is very very important, all these three quantities must be either in joule or calories. Means this delta Q, delta U and delta W, and all should be in either joule or calorie, because we are adding or we are equating, means calorie should be equal to calorie or joule should be equal to joule. Therefore these all three things should be in a one unit. All these three things should be in a one unit. Next one. Now, what is the limitation of this first law? This is very important. The limitation of this first law. So let's see limitation. What is the limitation of this first law? Isn't it right? So let's see what is the limitation for this. So see, this first law of thermodynamics does not indicate direction of heat transfer. From which point to which point the heat is going to transfer, it is not going to give you. Which one? This first law. Next, it cannot tell anything about the conditions and under which conditions, for example, heat can be transferred, or under which the heat will not transfer. These conditions it is not talking about. Okay, and it also does not explain why complete energy is not going to convert into mechanical work. Understand? These are the three limitations we can say. So I'm writing one by one. See here, number one, what is that? Does not indicate the direction of heat transfer. Does not indicate direction of heat transfer. Got it? It will not indicate any direction of heat. Second point. Next one. Here. Next one. Does not tell anything about the conditions under which heat can be transferred into work. Does not tell anything. Does not tell anything about the conditions under which heat can be transformed into work. Got it? This is second point. What are the conditions under which this complete heat is going to convert into work? It is not telling us. Next one, next point. Does not indicate this law does not indicate why the whole of heat energy why why the whole of heat energy cannot be converted into mechanical work continuously. What is the meaning of this point? Suppose you want to convert heat energy into mechanical work. For example, at before times we can say the train was running on, there was steam engines particularly. So that heat was going to convert into mechanical energy, and that's why that wheels used to rotate by using the heat only. So this law does not indicate anything why the whole heat energy, whole means complete heat energy, is not going to convert into mechanical energy. There is some losses. So they are this law is not talking about anything about that all losses or complete conversion of heat. Got it? So these are the limitations of this first law of thermodynamics. Got it? These are the limitations. So let's move ahead. Next. Now, sign convention. What are the sign conventions? So very, very important, these sign conventions. When you are solving the problem, that time you have to use sign conventions. Sign convention. Now, how many quantities we are having here? Only three quantities. What is that? Delta Q, delta U, and delta W. So I am making one small table. So you also make like that so that it will be useful for you. I am making like this table, sign convention table. First, let me make, and then later you try to make. First one, you write quantity in a first one. Wait, first see how I am making. And don't mix sign conventions of chemistry and physics. Our sign conventions are little different than chemistry. Next one is sign, and here it is condition. Okay, here it is what? The condition. So first we are having delta Q. So therefore let's take first quantity as a delta Q. This is the first quantity. Next one what we are having? Delta U, है ना? Yes. So for this I'm taking this column. Like this table you can make so that it is easy for you to keep it in mind about these sign conventions. So delta Q, then next one is what we are having? Delta W, W है ना? And तीसरा क्या है? Delta U, that is for internal energy. So here it is sign. So obviously what signs we are having? This is plus, this is minus, plus, minus, plus and minus. When you have to take plus delta Q, when you have to take minus delta T, that is what the condition is about, right? So let's see first one, plus sign when we have to use. When heat is supplied to the system, when heat is supplied to the system, when heat is supplied to system, that is delta Q is what? Plus. Delta Q is plus N. When we are giving heat, for example, pressure cooker, rice is there, you are supplying heat to that system, then delta Q is plus. When it is minus, when heat is drawn from the system, when heat is taken or drawn from the system, what we are doing, we are taking out heat. So refrigerator, whatever we are keeping, we are taking out heat only, yes or not? Then delta Q is minus. Delta W, so delta W is plus when work is done by the gas, when work done by the gas on the system, है ना? Obviously, so that is, you can say expansion also. So if suppose any piston is there or pressure cooker is there, pressure cooker you are supplying heat and suddenly that vessel is going up, and that is what, it is applying some pressure on the system, yes or not? That is what delta W is plus, work done by the gas, minus delta W is minus when when work done on the gas, on the gas, in this it is what, compression. अगर compression है, yes or not? For example, piston and gas is there, you are pressing down. So whatever the air is getting, it will get compressed little. That is what? Work done on the gas by the surrounding, or work done on the system by the surrounding. That time you have to take delta W as a minus. Delta W is plus now, or delta U is plus when with temperature rise, internal energy increases. When it is a plus means what? With temperature rise, internal energy increases. If it is delta U is plus, internal energy क्या होता है? Increases. Next, it is minus means with temperature fall, internal energy decreases. So with temperature fall, internal energy decreases. Internal energy decreases. Here, these are the what? The sign conventions which we are going to use in case of the first law of thermodynamics. Yes, note down. Yes, so let's move ahead and let's solve problems on this model. So let's take one small problem here, problem on this concept. Concentrate because I am going to give you some problems also at the same time. So you have to solve these all. Find the external work done find the external work done by the system by the system in kilocalorie when 12.5 kilocalorie of heat is supplied to the system, and the corresponding and the corresponding increase in internal energy is 10,500 joule, and given is what? Joule J is equal to, that is what, 4,000 mechanical equivalent, 4,200 joule per kilocalorie. Why they have given this? Because to convert this joule into kilocalorie, because already one is given, how much that is? This one, 12.5 kilocalorie, and this is in joule. So we have to convert that. That's why they have given this factor. So let's solve this problem first. So first of all, what is a given? You note down first given things. Find the external work done by the system in kilocalorie. So he is asking delta W is equal to how much? Next, heat is supplied to the system. Heat is supplied to the system. Delta Q. Delta Q is equal to 12.5 kilocalories. And next they have given delta U. Delta U is how much? 10,500 joule. Yes or not? Yes. So how to solve this? Okay. So how to find? So this is given. So you see here, this 10,500 joule is there. So we have to find, or we have to convert into kilocalorie. So conversion factor is there. That is equal to 10,500 joule divided by 4,200 joule by kilocalorie. So that is equal to, if you will divide this, you are getting how much? 2.5 kilocalorie. This is what your delta U. Now, just use formula delta Q is equal to delta U plus delta W. Now see here, work done by the system. Work done by the system means on gas. Hai na? Work done by the system means on gas. Yes or not? So you are getting what here? Minus sign. So delta Q is equal to delta U minus delta W. This sign convention. See here, work done by the gas means plus, but work done on the gas means compression, means system is pressing. So work done by the system means this one only. On the gas means work done is doing on gas by the system. So therefore here I have got minus. Then what is about delta U sign, sir? You see here corresponding increase in internal energy. Increase in internal energy means plus, so no need to change the sign. That's why here plus only. Next, delta Q, work done by the system. Work done by the system, है ना? And here heat supplied to the system. Heat supplied to the system means यहाँ पे देखो plus ये है ना? Therefore no need to change the sign of this delta Q and delta U. Only sign of this delta W will get changed, but we want this delta W. So let's substitute now. Delta Q we are having, so here it is 12.5 is equal to delta U is how much here? 2.5 minus this delta W. So therefore minus delta W is equal to 12.5 minus 2.5. है ना? This will go this side, and therefore minus delta W is equal to 10 kilocalorie. But this is delta W we want, and therefore this delta W is equal to minus 10 kilocalorie. Got it? Understand? So this is one problem I have solved. You understood how it is, how to convert from joule to kilocalorie. Just this division factor is there, right? So I will send some 2 to 3 questions. You try to solve that today also on this model, right? And yesterday's problems, yesterday's PV graph problems, so many of you have not solved. Please solve that also. Don't forget, if you will not solve, it is very dangerous. That time only you complete. If you have doubt, ask me. Got it? So like these problems you are getting on this first law of thermodynamics. Understand? Clear? Okay. So let's stop here. Enjoy the day.